To decide the future of a city, do you lock the doors and draft a blueprint, or do you build a prototype out in the open? Large-scale urban redevelopment usually works like a one-way street. Institutions decide what the problem is, and developers propose the solutions. By the time local residents are invited to the table, they are mostly there to leave a comment on decisions that are already in motion. The sheer scale and complexity of modern urban planning acts as a barrier. It distances the public from development power, treating the citizen voice as a required checkbox on a bureaucratic form rather than a meaningful design input. This is a map showing St. Petersburg, Florida. The city's historic gas plant district carries the heavy legacy of a displaced Black community. Today, the area also sits right in the path of escalating climate risk and infrastructural strain. Now city planning is adopting a new engine to process all this complexity: generative AI. Planners use it to synthesize data and generate models faster than ever before, but plugging an algorithm into a process that already struggles with transparency creates a sophisticated black box. If AI accelerates decision-making without strengthening consent, it becomes an incredibly efficient way to sideline community knowledge. When Steve Diasio approached the district's redevelopment in 2025, he started with a strict premise. You cannot assume trust exists. You have to design it directly into the workflow. When you overlap a history of displacement with the rise of opaque algorithms, explicit, auditable trust mechanisms become a mandatory baseline before a single brick is laid. In November 2025, 45 stakeholders gathered in St. Petersburg. City officials, developers, financiers, and residents sat down together for a one-day design sprint to map out a clean energy future for the district. This prototype newspaper page shows how the team pulled out community aspirations. They used future headline exercises to convert qualitative hopes into testable claims, like a projected surge in local ownership. Those qualitative hopes were then translated into strict parameters. The groups wrote design briefs containing specific metrics: 200 new co-ops, 14,500 jobs, and a 32% bump in household wealth. Formatting raw emotion and lived experience into hard data points forces the system to pay attention. It prevents developers from dismissing community input as unactionable sentiment. Armed with these structured briefs, the teams used GPT-4 and Sora prompt design to rapidly visualize their ideas. This image of a rooftop garden is one of those rapid visual outputs. Here, AI was strictly positioned as an option generator, not a decision authority. This kept the design anchored to the community's intent, avoiding aesthetic drift. Every output was treated as a highly contestable rough draft. Human teams governed the critique cycles to ensure the models stayed within the defined constraints. This scoreboard prototype condenses those concepts into concrete numbers. Here, the teams established a hard resilience metric, a microgrid that could keep local clinics powered for 96 hours during a storm. They took these metrics and drafted actual request for proposal language. This targets the exact phase where citizen influence usually evaporates: procurement, by writing the public's values into legally binding obligations. This workflow demystifies the technology. By putting humans firmly in the driver's seat, the AI functions as a supervised production assistant that works exclusively to serve citizen-defined metrics. The most transferable contribution to come out of the sprint was a mechanism called the legibility layer. This makes the entire AI-mediated design process transparent and publicly correctable. The system traces every piece of input. If a community requirement is altered or rejected, the loop explicitly documents the rationale behind that decision, making the edits completely observable. Showing people exactly how their contributions shape the final outcome bridges the accountability gap. It stops residents from withdrawing into cynicism, turning abstract promises into hard, auditable proof. The St. Petersburg Sprint provides a case study for how service design can evolve in high-stakes, technologically mediated environments. In this context, trust requires visible, verifiable checkpoints. And as civic systems rely more heavily on automation, the decision points of those technologies have to be mapped out in accessible language so people can actually understand them. Accountability has to be engineered at the very beginning of the process. You build a governance scaffold by establishing role clarity and testing for failure modes long before any irreversible contracts are signed.
This approach positions service design as a form of civic infrastructure, one that builds the specific conditions under which technologically mediated decisions remain transparent and steerable. A one-day workshop won't solve the deep financial and political knots of urban development on its own, but it proves that a better framework is possible. The next step is turning this methodology into a permanent civic operating system, one that continuously syncs community input with the actual milestones of procurement and delivery. Under this model, technology helps trace and solidify the public voice. It pulls citizens out of the role of passive commentators and places them right where they belong, acting as undeniable co-stewards of their city's future.